Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on hypothesis testing. So, diet plan is our scenario, and a nutritionist claims that the average loss for a new diet plan is 8 pounds. So, this is a claim, so we're going to assume that that is our population mean. Mean is 8 pounds. And we can go ahead and record that right here. The next thing, with a standard deviation of 1.9. So, we have our standard deviation, so we know this is 1.9. It's also pounds. A random sample of 35. So in this case, N is 35. Um, from a group of from a 2,500. So we have a large population here. All right, we're going to need that one for our conditions. Who follow the diet plan showed an average weight loss of 8.7. Average, that's the word for 8 point, that's a word for X bar, because that's our sample mean. This came from the sample. So our X bar is 8.7, and it's also in pounds. All right. Conduct a hypothesis test with an alpha equal 3% to determine what the mean weight loss is. Determine to determine that the mean weight loss is greater than 8 pounds. So we have an alpha equal 0.03. So our formula is T equals X, oops, X bar minus mu. Ooh, and it's not a T. I'm sorry about that. This is a Z distribution because we're working with the normal. We'll work with the T later. So Z equals X bar minus mu, standard deviation of the population divided by the square root of N. All right. In our later unit, we will talk about the T, but right now we're working with the normal, so it's a Z. All right. So if we were drawing our picture, we have a mean of 8 pounds, so we're centered on the mean. And we want to know the likelihood that we would get a sample of X bar of 8.7. And here's our mean, there's our X bar. And we're looking for this area right here. And they said greater than, so we need to be circling the greater than. We'll go ahead and plug in. So we're going to have Z equals 8.7 minus 8 over the standard deviation. And our standard deviation is 1.9 divided by the square root of 35. All right. The next thing, well, what type of procedure is it? Well, first off, how many samples do we have? We have one sample, and we already said it was a Z, and they want us to run a hypothesis test. So one sample Z test. All right. So we need to set up our hypothesis, and our hypothesis is going to look something like this. Mu equals 8 pounds, because that's what they claimed. The alternative is they want to know if it's greater, so mean is greater than 8 pounds. Our parameter, let mu equal the true population mean. And what did we care about? Weight loss. All right. Well, our first condition. Well, what is it? Our first condition was, is it a random sample? So we need to go back and look and see what, let's take a look at that real quickly. So the first condition is random sample. And when we look back, this says a simple random sample of 33. We're good to go. Random sample of 33. And that was given to us. Oh, excuse me. I was looking at the wrong problem. Random sample of 35. So this is the random sample of 35. And that was given to us. All right, we need to make sure our sample is not too big. So it needs to be less than 10%. So we'll go 35 times 10, and that equals 350. And when we look at this, What was our population? They gave us a population of 2,500. So less than 2,500. So N is less than 10% of the population. Finally, we have to check normality. First, we need to see, did they tell us it was normal? And when we read this, they didn't talk about the shape at all. So we don't know if it's normal or not, but it doesn't matter because our sample size happens to be 35. And 35 is greater than or equal to 30. So we can say normal by central limit theorem. All right, instead of saying central limit theorem, we're going to abbreviate by CLT, normal by central limit theorem. All right, so the next thing we need to do is we're going to actually need to run this test. So we're going to go up to blue button and, excuse me, we're going to press stat, arrow to test. And the very first thing is z-test, and that's what we're looking for. We're running a z-test. We want to make sure stats is highlighted because they gave us the statistics from the sample. And we're going to look at what we recorded. Well, we said 8 pounds. We had a standard deviation of 1.9. We have an X bar of 8.7, and we have a sample size of 35, and we said that it had to be a greater than, because they're claiming is greater than. When we calculate and we get Z equals 2.17. So we're going to write it this way. The probability that Z is greater than 2.1796 equals 0.0146. So our p-value is 0.0146. They told us above that our alpha was 3%, so we're going to put 0.03 or 3 divided by 100, make sure it's the same length. Well, 146 is definitely less than 300, so we're going to reject the null. All right? So our conclusion, our p-value is, what was it? 0.0146. How do we state this? Which is less than alpha equal to 0.03. What was our decision? We reject the null. All right. And then we get to say there is sufficient. You might want to use the word enough. I like the word sufficient because there's enough evidence to suggest what? Well, what were we talking about? True population mean weight loss. Is, well, what was our alternative hypothesis? Oh, we just need to put that in words. So that's greater than 8 pounds. All right, so that's the hypothesis test. I appreciate you watching. Hope this helped and look forward to seeing you on the next one. Thank you.